Where did everything come from? How did the universe begin? These are questions that have fascinated humanity for millennia. Today we embark on a journey to explore the Big Bang Theory, the leading scientific explanation for the origin of our universe. We'll examine the evidence, from the faint glow of creation to the shifting light of distant galaxies. Along the way, we'll also reflect on how ancient wisdom, including verses from the Quran, resonates with these discoveries. This isn't about forcing science and scripture together, but about appreciating the different ways we seek to understand our origins. Let's begin our exploration of the universe's greatest mystery. For centuries, people believed the universe was eternal and unchanging, a comforting logical assumption. But a simple question, known as Olbers Paradox, challenged this view. If the universe is infinite and filled with stars, why is the night sky dark? If stars stretched forever, the sky should blaze with light. The darkness between the stars is a clue. The universe can't be infinite in age or size. It suggests the cosmos has a history, a beginning. The night sky's darkness means the light from the farthest stars hasn't reached us yet. This paradox hinted at a universe far more dynamic than anyone imagined. The answer would come not from philosophy, but from a new understanding of gravity and space-time. The stage was set for a revolution in cosmology. In the 1920s, Georges Lemaître, a physicist and priest, studied Einstein's equations and realized they predicted a dynamic universe, one that could expand or contract. Lemaître proposed that if the universe is expanding now, it must have been smaller, denser, and hotter in the past. He imagined all matter compressed into a single primordial point, the primeval atom. This was the birth of the Big Bang Theory. Everything emerged from a single moment of creation. At first, the idea was dismissed as too radical, even unscientific. But Lemaître's insight challenged the old belief in an eternal cosmos and opened the door to a universe with a beginning. The search for evidence began. The breakthrough came with Edwin Hubble's observations in the 1920s. Using powerful telescopes, Hubble discovered that distant galaxies are moving away from us. Their light is redshifted. The farther a galaxy, the faster it recedes, showing that space itself is expanding. This was the first strong proof for Lemaître's theory. The universe is not static, but evolving. Winding the clock backward, all matter and energy converge to a single dense origin. The darkness of the night sky was finally explained. The universe has a finite age, and the light from the most distant galaxies is stretched beyond visibility. Hubble's discovery transformed our understanding of the cosmos. The universe had a beginning, and a story written in light. The Big Bang Theory was no longer just an idea. It was becoming scientific fact, but more evidence was needed. If the universe began in a hot, dense state, there should be a faint afterglow, the cosmic microwave background, or CMB. In 1965, Arno Penzias and Robert Wilson accidentally discovered this ancient radiation while calibrating a radio antenna. The CMB is the oldest light in the universe, a relic from when the cosmos was just 380,000 years old. Its uniformity, with tiny fluctuations, provided the seeds for galaxies and clusters. This discovery cemented the Big Bang as the leading model of cosmology. The CMB is a direct window onto the dawn of time. With this evidence, cosmology became a precision science. The story of the universe's birth was now written in the sky. Scientists have long wondered how the universe might end. One early idea was the Big Crunch. If there's enough matter, gravity could reverse the expansion, collapsing everything back to a singularity. But recent discoveries, especially dark energy, suggest the universe's expansion is accelerating, pointing to a big freeze instead. Interestingly, ancient scriptures also speak of cosmic beginnings and endings. The Quran describes the heavens and earth as once joined, then separated, a striking parallel to the Big Bang. It also mentions the ongoing expansion of the universe. These verses encourage reflection on the cosmos as a sign of a greater reality, Science and scripture, though different in purpose, both invite us to ponder our origins and fate. The universe's story is written in both the stars and our oldest texts. The Quran also describes a dramatic end, the day when we will fold the heaven like the folding of a scroll for books. This imagery echoes the idea of a universe collapsing in on itself, a cosmic finale. While the Big Crunch is less likely today, the alignment between ancient descriptions and modern theories is remarkable. The Quran is not a science textbook, but a book of signs, encouraging observation, reflection, and the pursuit of knowledge. It invites us to see the universe as both a physical reality and a source of spiritual wonder. Science and faith, far from being at odds, can be complementary paths to understanding. The story of the Big Bang is our story, the story of where we came from. Whether through physics, faith, or both, it connects us all. Let's keep asking questions, seeking knowledge, and reflecting on the cosmos. Thank you for joining this journey. Peace be with you.